By 600 BC, the Greeks knew that if you took a piece of amber and rubbed it with wool, the amber would attract dry leaves. And in Greek, the word for amber is electron. Now, here I have a PVC tube. It's a non-conductor, and here's a few pieces of paper. And if I bring the PVC in the vicinity of these little scraps of paper, nothing happens. Now, if I put two non-conductors like silk and PVC together, there will be a transfer of electrons from the silk to the PVC. And that's because the atoms in the outer surface of the PVC hold on to electrons more strongly than the silk does. And so rubbing actually enhances the amount of contact and increases the amount of charge transfer. So I'm going to rub the PVC tube with the silk to increase the amount of electrons that are transferred from the silk to the PVC. Okay, now we're going to look at the effect of this charged PVC on those scraps of paper. Okay, so you can see how the paper jumped up. A lot of them hit the rod and then bounced away, and there's one that's sticking. Okay, so let's explain what's going on here. Okay, so let's think about looking at this piece of paper edge on and modeling it in the following manner. So these pluses will indicate the location of the atoms in the paper, and the pluses can represent the positive charge associated with the atoms, and these negative signs, the negative charges. Now, the paper is a non-conductor, so the electrons aren't really free to flow, but they can move a little bit under the influence of an external electric field. So for instance, let's bring in the charged PVC tube. So the PVC tube becomes negatively charged when we rubbed it with silk, and so I'm showing that excess of electrons here on the outer edge of the PVC tube. Now as it comes towards the paper, what will happen is the electrons around the atoms will be repelled, and the positive charges associated with the nucleuses will be attractive to the PVC. Now, the electrons aren't free to flow in the paper, so they'll only move a little bit, but this does what we call polarization, causes a polarization of the material. And since the positive charges are closer to the negative than the negative ones that have been pushed away, there will be a net attraction. So the paper will be attracted to the PVC. And what can happen is the paper can just stick there, or if some of the electrons transfer from the PVC to the paper, all of a sudden the paper is negatively charged, as is the PVC tube, and the paper will fly away. And that's exactly the behavior we were seeing. So I'm going to again bring the negatively charged PVC tube in the vicinity of these scraps of paper. The paper will become polarized and then get attracted and jump up to the PVC, where some of them may acquire electrons, become negatively charged, and then bounce away off the PVC tube. And some of them that don't acquire the electrons are polarized and will stick to the PVC.